Good evening, everyone, and welcome to today's session. And we will start our journey with big data. Now, I'm assuming majority of you have already completed your data science journey. In data science, what did we learn? In single statement, I want somebody to answer this. What did we learn in data science? Data processing. Very good, Ashna. That's right. We are basically learning how to process the data. And this processing will help us derive insights, and those insights will help us make better decisions. Right? This is what we are trying to do. Now, if I talk about an organization, especially now in the pandemic times, all the organizations have gone to become, they've become digitalized, right? So that means organizations are started or they have started collecting the data, right? Now everybody understands that data is the new oil, isn't it? Because if you look into the data, it would tell what we have done till now, and from that retrospection, we will know what can we do in a better way, right? It would basically hide a lot of secrets, and we're trying to process it to extract those secrets. Ultimately, the objective is to make informed decisions so that we get profits. Ultimately, this is the underlying objective which drives all the businesses, right? All the innovations in the businesses are driven by profits. And hence, we basically give utmost importance to data. But what is the size of the data that we are looking at? For an organization, if I talk about, what is the amount of data that we are looking at, right? It becomes very, very huge data. And if I have a huge amount of data, I cannot use traditional tools to process that, isn't it? We cannot process it. See, how does business start? A business starts in a very small size, right? This is startup. As in how the business grows, the amount of transactions that we do in the business also grows. That means proportionally the data is also growing, right? Now, if I have 100 records, maybe I have only one client to start with. As a startup, probably I have just one or maybe two clients. And I have 100 transactions. I can use manual methods to process that data, right? This is what happened before computers. As in how the number of clients are growing. Let's say now I have 20 clients. So proportionately, the amount of data that we have is growing. So let's say it's becoming 1,000 transactions now, right? Now, if I ask you to manually evaluate this, it would become a little tough challenge, tough ask. What if I have 200 clients? My data would become even more, furthermore increasing, right? Data is increasing. Now, here I will definitely not be able to process the data manually, and that's where your computers are coming into picture. And you're using these automatic mathematical concepts. That's what we have learned, algorithms and all that. Now, what if I'm still continuing to do the business, and this time I have 2,000 clients, or maybe for the 200 clients itself, the number of transactions has just grown. Because of digitalization, the number of transactions that we are seeing is bombarded. It's grown beyond our imagination. Right? In this case, what should I do? I have computers, but are these computers good enough to process the data? That's a big question. So here, if you see the size of the data that we are talking about, it became huge, right? So we are talking about big data. Now, on this big data, how can we analyze or how can we process it? What all various techniques that we can use to store the data and process the data, right? So that's what we are going to understand as part of the sessions. And predominantly when we say big data, these are the two tools that you have to look at. This is a very chubby looking elephant, which is the logo of the software called as Hadoop, is basically started everything. This is like a groundbreaking invention in digitalization, which helps organizations to process the huge amount of data that we are seeing in current date. So we need to understand the dynamics, guys. We need to understand the scenario that we are dealing with at this point of time. That would allow us to understand what various challenges we will have to process the data. If you understand that, then you will also try and understand how we can process it in a better way, right? So let us look into all these different modules. At a high level, I'm drawing this. We'll talk about big data and its challenges. Then we'll talk about Hadoop and how actually Hadoop started. Then this Hadoop is a framework. If you see, we're calling it as framework. So on that framework, what are the various softwares that we can use? And finally, we'll look into the new age software called Apache Spark, my favorite, of course. And we'll try and see how it actually helps in processing the huge amount of data that we are looking at in today's world. Now, introduction to big data. I've just given you a brief idea about what is big data. And you already know what is big data, right? There's no standard definition for big data. And this is...
Hello, sir.
Yeah, who's this? Yeah.
This is God. Sir, I'm not able to understand clearly the difference between data, normal data, and big data.
We just started, Gautam. You need to hold on. I'm giving you multiple examples. You'll understand.
Okay, sir. Thank you.
Yeah. End of the session. If you have the same question, then yeah, you might want to ask that point of time.
Okay. Thank you, sir.
Yeah, sure. All right. So we see what is big data. This particular definition that we are seeing, or I should say, this is an example that Mr. Eric has given in one of the interviews that he was facing. He used to work for Google, okay? Till 2015, he worked. Now he's working for Alphabet. Now, this gentleman was asked a question in one of the interviews related to some kind of a awareness program or something like that. The reporter asked, what do you think about big data, or what exactly is big data? It's not directly related to big data, but the example is so well suited to understand what is big data. And this is also something that I regularly use in my trainings. All you have to do is imagine that you are a god, right? And you decided to store the data. Right? And Eric added that if you were God and you started to store the data, then humanity, since its inception means when humanity started, right? Humans existed from that time. So in your childhood, as you might have studied about Adam and Eve and all that, right? So from those days, everything that humans have did, you started to record. Now, if you did that, then you would be collecting 5 exabytes of data till 2003. This is what Eric gave an example as, to give you the idea about what is the amount of data that we would collect. So till 2003, he is saying 5 exabytes of data. Now, what is 1 exabyte? What is 1 exabyte? Anyone? Let me try and write it. What is 1024 MB? 1 GB. This is something everybody knows. What is 1024 GB?
1 TB.
Yes, this is also something that majority of the people know. What is 1024 TB?
1 pp.
1 petabyte. PB. Now, what is 1024 petabytes? This is your exabyte. Zettabytes and yottabytes come later. This is your exabytes. So we are talking about 1024 into 1024 into 5. What is this? GB. This is the amount of data that you would have collected, right? But the interesting fact that you need to look at is, he added saying that the same amount, that means 5 exabytes of data, is now being generated in every 2 days. Now, this statement came where in somewhere around 2010 or some 12, I don't remember exactly the date, but a very pretty old statement. So every 2 days, you would have collected 5 exabytes is what he's saying. So till 2003, from when we don't know, you have 5 exabytes. So ample amount of time to load the data, right? But every 2 days after this 2003, you have 5 exabytes. In today's date, I would say every 2 hours, we are generating more than 5 exabytes. Maybe because of pandemic, especially, it might have grown to even 2 minutes. We don't know, isn't it? So what is the aspect that we need to look at from this example? What is that main aspect that we need to look at here, guys? We need to see the size, friends. If you're talking about every 2 hours of 5 5 exabytes of data, then in 1 day, how much data we are collecting? Even if you say 2 days, in 1 month, how much of data you are storing? You're generating, sorry. Right? So the size is the biggest fact here that we need to look at. So your big data is explained using these 4 V's, which is standard. In fact, I should say only 3 V's, but yeah, because the definitions are now changing, we need to consider this. The first V is the size. Humongous amount of data is getting generated across the globe. 2 days, 5 exabytes. Then 10 days, it is 50 exabytes. 30 days, it is 150 exabytes. Right? So the data is growing like anything. Then we look at the speed at which the data is getting generated. Now, from the humanity inception till 2003, 5 exabytes is something we can manage. It's slowly getting generated. You'll be able to slowly store and process it. But every 2 days, you are getting the same amount of data, or maybe 2 hours now. So you need to have systems which can actually work at that speed also. So size, then we are also worried about the speed. Now, if you have to generate such a huge amount of data at such a short span of time, then your operational data would not give you this volume. If you talk about an employee database, for example, which is in a proper table format, operational data I'm talking about, the numbers that we see in our regular data, that would not be able to give you this kind of a volume. The size is increasing so much because we are now seeing unstructured data getting generated a lot. Especially videos, they consume a lot of storage space. Size is getting majority of the times impacted by the videos, right? And even if you look into the current data that we are seeing, Netflix, YouTube, right, your online streaming applications, they consume the majority of the bandwidth on internet, isn't it? If you use your mobile and try to watch YouTube videos, your internet bandwidth that you have purchased would drain off. If you use WhatsApp chat for completely 1 month, it may not be able to consume even 1 GB of data for the entire 1 month, isn't it? So we are looking at the structure of the data, and videos consume the majority of the structure. Then we also have this new V in the picture. There are a number of different V's, but veracity is also something which is being used of late to define big data, because all the organizations are trying to collect the data. Data is there everywhere. It's getting stored. But what is the fact of the data which you need to use? How correct it is for you? What kind of truthful information that particular data is holding, which you are trying to process, right? So that is called as veracity, which talks about the correctness of the data. These are the 4 V's. I'm a traditional guy. I again keep saying, I would want to understand big data using these 3 V's only, right? So if I look at a different set of V's, I have value, I have visualization, I have variability, validity, volatility, etc., etc., etc. You can see 50 odd different V's are there, which are explained. But the definition, the main definition of big data can be understood by using these 3 first V's: volume, velocity, and variety. Rukesh, it's a common sense question, Rukesh. What kind of data is there in Facebook? What kind of data is there, Rukesh? Yeah. What all things we do on Facebook? We write posts, we share videos, we share small images. Exactly. So can you take a guess on how much data it is consuming? Don't you think it is big data because it has volume into consideration, velocity into consideration, and variety also into consideration? All the 3 things are there, so it qualifies into becoming a big data. Now, how much exactly, I don't know. I don't hold the database, right? I'm not sure. Facebook might keep changing the numbers. You might have to look into the Google to see exactly what is the amount of data on an average, of course, that they are capturing on maybe 1 month or 1 hour. If they share that information, we should be able to see that. You can Google for that exact number, Rukesh. Yeah. But understand the concept here. What is the format of the data, at what speed it is generating, and what could be the size of the data? That's more important for you to define as whether the data is big data or not. No, that's okay, Rukesh. I'm just clarifying you what you have to look at, not the size. Exact size is not required. That's not our concern. Right. So this is about the definition of big data, guys. Hope everyone understood what is big data from the definition perspective. So these are a few of the devices that we actually used in our history, in our past. Did anyone work with floppy drives? This is again, a regular question I keep asking. I just want to see if there are any people who are of my age. Oh, a lot of people are of my age. Okay, good. You saw. Okay. So floppy drives is something that I started working, and then of course it used to hold 1.44 MB. Then we also have different floppy drives which used to hold more data also. Then from there we move to flash drives. Of course, you have CDs and then DVDs and then flash drives. And now we are talking about what? Cloud.
Sir, excuse me, sir. Sir,
Yep.
do you have any floppy disk with you, sir, in real time?
Not sure. I need to see.
Because many wouldn't see, have saw the floppy disk. If you have during the classroom session, you can show it, sir. Because I also didn't see right now, sir. Till now I also didn't see.
Sure. I'll see if I'll dig into my archives. If I see any floppy drive, I'll definitely bring that. Yeah. Maybe I should have something like prized possessions. I might have. I have CDs and DVDs, that's for sure. But floppy drives, I need to check. Yeah, so we'll see. All right, so what is that we are looking at now, guys? What is the main storage device that we use now? Cloud. Main storage, I said directly or indirectly, everybody is using cloud. The example is Google Drive. If you have Gmail, you'll be using Google Drive. Your emails are getting stored on cloud, right? So by default, the most important storage component now is cloud. And remember one thing, cloud can scale itself for your requirements, right? It's not like your hard disk where you fill up your hard disk and then you want to change the hard disk for a bigger hard disk. It doesn't work that way. It can expand. Now, how is it expanding and all that is what we are going to learn, right? So underlying concept of cloud infrastructure is something that we are learning here. Now, in the future, near future, you're going to see quantum computers. It's a new technology altogether. And a lot of noise is being made around this quantum computers. It will take a lot of time, of course, but this is something which allows you to do very, very quick computations. And especially in the space of AI, quantum computers are being used for doing benchmarking, in fact. Right? So I'll show you one news which Google did, experimented. Google quantum computer, less than 4 minutes for 10,000 hours problem. There's something related to this. Yeah, Google says its quantum computer has just completed a 10,000 year task in less than 4 minutes. Yeah. So what does that mean? This news came way back in 2019, guys. October 23rd, to be precise. Google is claiming that they had a 10,000 year problem. This basically is the timelines to solve that problem. That means if you are using your regular computers, then there is a complex problem which Google has, which would take 10,000 years to solve if you start working on that problem, right? So that's the estimation. 10,000 years is the estimated time. for regular computers. Now they said that their quantum computer, it solved same problem in less than 4 minutes. Now, how crazy is that? We're talking about 10,000 years task in just 4 minutes. Now we are talking about a completely different league of computers, isn't it? You might want to read this article, guys. Okay, just try to experiment or explore this. Sorry, want to explore and read about what does this actually mean. Why Google is trying to make such claims and all that. You might want to talk about it. So this is something we are going to see in future, of course, but it will only be available on cloud platforms. IBM is already working on right, these quantum computers and all that. Very soon, probably in another 5 years, we might get hands-on. There is restricted access for Google, this quantum computers for only few people, not for everyone. But probably it will be made public for everyone to right, start exploring quantum computers very soon. So the point that I'm trying to drive here is, as and how the technology is evolving, we as people are becoming more and more digitalized, or I should say digitized. All the organizations, right, are becoming digitized. A small vendor who's trying to sell, let's say, vegetables on roadside, they are also using online transactions. QR codes are being used, and we are making the transactions using these online mobile wallets, right? So the technology is growing. So you need the devices also growing, right, in growing spree, and that's exactly what this chart shows. Way back in 1980s, if you see, the cost of hardware devices, the cost of 1 gigabytes in USD is given as this much, 10,000 to 100,000. That's what the data shows. But now this is only till 2015, because after that it is almost like free. Right? What is the amount of right, investment that you will do to get a 1 GB storage space? Sorry, 1 GB, right? My bad. 1 GB, how much cost would you put? Exactly, free. You open a Gmail account, don't do anything, just Gmail account, you get 30 GB for free. Not 1 GB. 15 GB, no 30, right? I have 30 GB. Okay, fine, 15 GB, fine. Maybe I have a different account, corporate account or something like that. So 15 GB is what you're going to get, right? If your account, I mean, just open 2 accounts, you'll get 30 GB. What's in them? Isn't it? Yeah, 2 IDs. All right, now you can extend it to 1 TB or whatever that amount is. But they will charge after that, and you can calculate how much it would cost for 1 GB if you're really going there. And you can also check on the cloud platforms. The cloud platforms, they charge very, very, very less for 1 GB storage. Very less on cloud platforms, right? So to support the amount of data that we are generating, the hardware devices are also becoming much cheaper. Okay, right. Now these are very interesting insights. This is something that I keep talking about again. I love these examples, right? That's the reason why you see in all our trainings, I try to portray these examples. Bombardier basically is a very big organization, which is into manufacturing the railway engines, railway compartments, then aeroplanes, right? These kind of things. So they have showcased a new jetliner engine for aeroplane. right? This is again way back in 2013, 14, somewhere around that time. Very old information I'm talking about. But look at what they say. Sensors are fitted to these engine, and these sensors, one engine, right, a small C series jetliner, it's a fan based engine, it captures 5000, it captures 10 GB per second information, right, from these 5000 sensors. You can imagine how much data it would generate if it is going for a 1 hour trip. 60 minutes. So you'll get 60 minutes into 60 seconds into 10 GB in 1 hour. That's the amount of data these 5,000 sensors are capturing. Now, a single twin engine aircraft, that means it will have two propellers like this, right? And this twin engine small aircraft where 2 or 3 people will sit, it has gone for 12-hour flight journey, assume. Then it is said that it has captures 844 terabytes of data. Now the question to you all, let's assume that you're working for a aviation sector. You're working in, let's say, one of the terminals, airports, right? One of the tower, which controls all these flights and all that. And you're responsible to gather all this data. So you have half of your day collecting 844 terabytes of data. Now let's say you're working only for half day. So what if you're working for 30 days? Right? You're only looking into half of your day effort. So you'll see 844 into 30 terabytes of data. Now, if I talk about 1 year, this is the amount of data that we're talking about, roughly. Now, the question is, where do you store this data, even if you are talking about 1 day? Do we have a system in place where I can store 844 terabytes of data on a server? Maybe you would say that, yes, we have servers, we can invest and we can purchase servers which are capable to store petabytes of data. Let's say we have 100 petabyte storage computer, right? Now, if I talk about 100 petabytes storage capacity server, then for how many days I will be able to use it? Yeah. So maybe I'll say 1024 terabyte. That's 1 petabyte into 100. But after that, what I do? Where should I put that data? Yeah. Let's say after 100 days, or maybe you will say 150 days, the server is getting filled up, right? After 150 days, assume, just a rough number, your server gets filled up, right? So what you do after that? And on this data that we are talking about, it is only for one engine or one flight, one aeroplane. How many such aeroplanes are there worldwide? How many trips do they make? You can do the calculation. I imagine those calculations to you, right? So think about the practical challenges that we have to work with here. I see a lot of messages. Let me see. We don't have cloud in those years, Abhishek. Cloud is something which is popular now. Cloud came after these big data systems, right? We don't have big data. So there was no cloud in that time. So in such case, what you do? Serious challenge, right? In real-time scenario. Mihir, Those times, if you talk about 20, 30 years ago, maybe they would not have these sensors. 5,000 sensors could not have been there, but 3,000 sensors could have been there. Maybe not 844 terabytes, but 100 terabytes were there. But those days, do we also have 100 petabytes capable systems, servers? You also have to think from that perspective, right? If I talk about let's say 30 years back scenario, I can't even imagine that. 30 years is the 1970s, right? So yeah, I don't even want to talk about those years. Let's talk about, let's say 20 years back, or maybe 2000. Let's say 2000, 10 years back. i3 was a very good system. i5 was awesome. i5 was a very costly device, right? 2000s. If I talk about early 2000s, right? 20 years back. Right? If I go to 1990s, then yeah, 30 years back, yeah, I think storage device was also very similar. I mean, we used to have floppy drives in those days. 1.44 MB. CD-ROM was like a big thing, and CDs were used to capture 700 MB or data. Now, even if I talk about 1 TB those years, it is the same, proportionally it is same, right? The effect is same. See, devices are becoming smarter, so IoT sensors are being used. Yeah. Mahesh, I'm saying that cloud came afterwards. Now you are aware of cloud, but what was the scenario when cloud infrastructure was not there in place? Yeah. Can you imagine that? Cloud, you'll understand how the cloud technology is working after we complete right few sessions in this particular scenario. So cloud is something which came after big data solutions were designed. Right. So this is a scenario, guys. Okay. Well, there are a lot of ifs and buts and all those things. You can imagine that. Let's not get diverted. Our focus is to talk about how these practical challenges were addressed. Okay. Another example, pipeline, gas pipeline. Again, here also a lot of data is getting generated. Right. Majority of the data that we will see nowadays is automatically generating thanks to these smart devices that we have, right? And majority of them are using IoT sensors, or I say IIoT sensors. So the Aramco has gas pipelines, which is of 650 kilometers range, and these pipelines are passing through red sand dunes. Red sand dunes. Or you can also imagine the gas pipelines that we see, which are there across the globe. They're also passing through undersea. Now, how can you monitor this gas pipeline? We're talking about gas pipeline. Yeah. There will be corrosion, there will be leakages, etc., etc. That's the biggest problem that pipelines have to solve. So in order to maintain the pipelines, we cannot put humans in those conditions. So what we do, we use these sensors. We fit in the gas pipelines with sensors inside the pipelines, and these sensors capture the amount of gas that is passing through them. Right? Let's say this is how the sensors are placed. There will be pressure, right, in the gas pipeline. So as and how the gas pipeline is passed, so 100,000 sensors were used by Aramco for those 650 kilometers. range of pipelines, and it captures every drop of your gas or oil which is passing through these sensors, right? So if you capture the amount of gas or oil passing through this sensor, then at certain distance you will have another sensor, so you also capture this. The reading has to be consistent. If it is not consistent, that means there is some kind of a leakage here. There will be another sensors, robots, which go to this area and try to address this particular area where you have corrosion from inside, right? So this is how the gas pipelines basically are maintained. Now we are talking about sensors which pass or which generate data relentlessly every 1 second. You would have multiple readings. Even if I say one reading per second, it will be more than that. But if I say 1 second, one reading, you're continuously monitoring these right sensors for these readings, and you'll have 100,000 such sensors. One day, that is 24 hours. If you say 24 hours, I'll multiply that to 60, right? So that I get minutes, and then I'll calculate that with seconds. And this is for one sensor. So if I add 100,000, then these are the readings that we are seeing in our data for one day, right? So you can imagine. I'm talking about seconds. Sorry, this is only in minutes. I have to add another 60. Yeah, this is the amount. Humongous amount of data. Where do we store it? How do we process it? Right? So think about these challenges, guys. Remember one thing. The world we are living right now is basically is I should say driven by data. And these organizations, Facebook, Alphabet, IBM, Oracle, Microsoft, they are the companies, the organizations which are crazy about the data. They understand the importance of data. And that is the reason why a simple mobile application, which is used for messaging. Before WhatsApp, we used to do SMS, right? We used to send messages over our mobile network. Then as and how the internet started coming up, people started slowly using WhatsApp. There are various other applications also, but WhatsApp became popular. What is there in WhatsApp, which is basically captured Facebook's attention? We are talking about $22 billion deal. What is there? It's just a WhatsApp, right? Facebook also has messengers. Facebook is also a public profile where a lot of people discuss. But remember one thing, Facebook talks about public discussions. It's a social media profile, I mean social media network where people discuss something which is in public. WhatsApp is a business channel where people discuss privately. So a lot of sensitive information can be extracted from WhatsApp messages, and that's what Facebook was behind. And yeah, $22 billion dollar was put in by Facebook to acquire it. Data is the key. With data, they can get information. And yeah, of late in India, I've seen the message, not sure about other countries. Yeah, so yeah, there's a lot of speculation now happening with respect to Facebook security policies and all that. You have to be careful. However, you are careful, guys. Remember one thing: we are living in digital world, and we have digital imprint, and organizations are watching us. Simple. You cannot escape that, right? So yeah, this is all the various business deals that we are seeing, which basically focus on one thing, which says data is the key, and we are talking about humongous amount of data, not regular data, right? They are not fools to invest so much of money, remember. Yeah, right. Now, and this is of course something you can also check. This is in 2019. I have to see for 2020. Probably I'll update this slides. So in 60 seconds of your lifetime, this is the amount of data that is getting captured. This is in 2019, friends, not 2020. We are in 2021 now. So we should definitely be looking at 2020, but right, because of COVID, we might see staggering numbers here. Right? If somebody would have done the research, probably we should be able to get that information online. Maybe we can check that. But yeah, 60 seconds of your life, that is 1 minute, just 1 minute of your life. This is the amount of data that is getting generated, or you can say used or accessed across the globe. Humongous amount of data. Look at that, Netflix.
But in 2020, it will be high now, sir. Because of COVID, many are using the same applications repeatedly, sir.
I was saying the same thing, right? I just explained that. I said 2020 would be interesting to see. Not sure if anyone has did this kind of analysis and gathered the data. We are not sure. I need to check for this kind of information online. Yeah, this is something which is available on Google. You can check for 2020 also. And definitely the data would have doubled, maybe even more than double. So year on year, the amount of data that we are generating and managing is going to increase only. It's not going to decrease. And COVID has completely changed the dynamics of human lives, right? So yeah, definitely it would have been changed. But this is only to represent, I'm trying to project the idea of digitalization impacting our lives. Okay. So this is another very simple example that we'll try to understand now to see how the business is transformed. Let's say you are the owner of this grocery store, right? We generally call it as general stores, right? So let's say a corner store, somewhere in the road at a corner, you have the store. It's a family owned business. You are the proprietor or you are the founder of that store. You are there and probably your family members are there to take care of the business, because the number of footfalls, the customers that you're seeing would be probably very less. Now, if I talk about a day's transaction, what can you imagine from the data perspective in one day? Not the size, what kind of fields you would capture? What data would you capture, friends, if this is the scenario of your business? Sales, okay, let's say customers. Somebody said sales. So let me add that sales. Transactions, okay. Sales or transactions would mean same. Profits, yes. Tax, very good. This is something new. Customer details will include phone number, email, etc., etc. Stock, very good. Sales, product sold is included in sales. For a standalone general stores, would you take feedback? Would you record that? I don't think you will record feedback there. Stock, inventory. You'll also look at your vendors, suppliers. So this is the generic data for your business. CCTV footage is security related. I'm not talking about that data. We're talking from the business perspective. Maybe these are the things that you will record. Maybe one or two will be there additionally. But this is the fields that you would collect. Now for these fields, how much data would you think is going to get generated in one day? How many customers would come for business to you for one day? Maybe 20 odd customers? 1,000. Huh? Karthik, I'm talking about a general store. I'm not talking about a supermarket. Even in supermarket, you will not see 1,000 sales on days. So in a general kirana store that's what we call, or general stores, maybe 10 customers is something that you might say every day you will see. So even if I say exceptional, let's talk about 50 customers visiting your store. They will be purchasing one or two or maybe 10 different items. So you will be able to create all this data in an Excel file. Simple Excel file can be good enough to deal with this. So on daily basis, if I talk about an Excel file, 10 MB is more than enough. 50 MB is also, yeah, maybe if I take exceptional case, 50 MB is good. But Excel file, I don't think 50 MB would be required, right? I'm just rounding it off to 10 MB. Now, if I give you a 10 MB Excel file, do you require a big computer, a processor, a software, and all that to process? Not required, right? We do it manually. We used to do it manually. If you remember all the general stores, they used to give handwritten bills. At least in India, that's the scene. We're not talking about other countries. But we will be able to deal with this using our regular systems, regular hardware. Now, because you are all data scientists, or at least have the concepts, right, have the idea of data science. Now, I would want you to ask or think on what kind of analysis would you be able to do on the 10 MB data. Yeah, that's important, guys. Any data that you get, you need to be able to do some kind of analysis, whether it is manual or using automated techniques, because you're data analyst or data scientist, right? So you have to come up with some strategies by analyzing the data. Market basket, maybe not. You have very little amount of data, little amount of products. You not have wide range of products in the store. Market basket is something not required. Sales, exactly. What is the popular item? What is the stock management, supply management that I'm talking about? Do we have the products appropriately stocked up? Who are the regular customers who are visiting, right? Which products give you more profit? What are your daily commodities, right? These kind of things is what you will be doing. Analysis. Recommendation is not required. If you have 10 odd products, what recommendations would you do? So you will have a very limited scope of analysis, but still you should be able to do it, right? Yeah. How many purchases are happening? How many returns are happening? Those things probably you will have to think about. Keep track of sales and products and all those things, right? So these are the basic things that we can do with this data. Okay, you try to maximize your profit, understanding which products are giving you profits and all that. Customer analysis, who are purchasing more, who are regular customers, who are not visiting regularly, right? So all those things will have to be done. Now, these things can be done using your regular laptops or systems, basic systems, so are good enough to handle this data. Now, let's say the business that you are doing is becoming more and more popular because population is increasing, of course. So more number of footfalls are coming. That means you're seeing more and more customers visiting your store. So as and how your business grows, your number of customers would also grow, right? So you decided to take up a loan or something, and you have probably set up a big store, supermarket, right? So when you say supermarket, the number of products that you're going to sell, will also increase, right? So the number of products increase, the number of customers increase, everything is increasing proportionately, right? So the amount of data will also increase. Simple, directly proportionate to the transactions that are getting generated in the business. Now, if you generate 1 GB approximately on a given day, probably your system may not be sufficient to handle the data. So what did organizations do? They said that, hey, let us purchase softwares which can actually help us manage and process the data in a better way. This is where organizations have seen the usage of database softwares. These database softwares were based on RDBMS concepts, relational database management systems. And these systems store the data in tables format. This is one table, this is one table, this is another table. So we'll have the tables created, multiple tables created for different aspects. And to get the entire information from this data, we use relations between them, right? And hence the software is called as relational database management systems. And we use SQL queries to process or work through this data. So this is how databases come into the picture, into the businesses, guys. Prior to databases, it was all manual, right? So this is database management systems growth. And remember, whatever the analysis that we are trying to do here will be done at a larger scale. Now you can also bring in additional aspects on recommendations, maybe not to the full extent, but association rules is something that you might definitely want to apply here. Product relationships, right? Different ad campaigns will basically have to be analyzed, and generalization of the transactions should be applied. Your customer analysis will be done. So a lot of additional things will come into the picture to your business now. And to support all that, you'll also have data, right? Data is getting generated. So to support all that, we also have data. Yeah. So this is how we have to see the business is growing, guys. So ultimately, it is the demand, the supply, and the data. But because data was not captured digitally, all these years, people did not understood the impact of the data that could actually give to the business in a positive way. The impact that creates is later on understood, right? So the systems also developed and all that happened. Anyways, now let's try and understand the scenario where your business that you are doing from your general stores, it became a superstore. From that superstore, let's say you are now into a franchisee business, right? So there are multiple stores that are running across the city. You have different branches, let's say. So if you have multiple branches, let's assume 20 branches in the city, collectively, all those 20 odd or 30 odd stores, assume is generating 30 GB data per day now. One store is generating 1 GB. So all the stores together generating 30 GB per day, assume, okay, it's not something that I'm giving numbers here, it's just an assumption that you have to make. So 30 GB data. Now what you do? If you have 30 GB of data, how do you deal with this 30 GB of data? We can do a lot of analysis, guys. The first thing that we try to understand is competitor analysis. And I also want to do variation analysis among the 30 stores. Which store is doing better? Which store is not doing better? Which products are being performed? Which products are performing well in which stores? Right? All these kind of different analysis I can. Which ads are affecting the sales in which particular branch? Can I also do forecasting of the sales or the demand of different products in different stores, right? Cost optimization, supplier management, etc., etc., etc. There's so much of scope that gets created now because of the business volume and of course data volume. Now, what would you do if I have 30 GB storage space? You cannot use your regular software, remember. Okay? You cannot use a regular software. So you would have to go for a higher configuration server, right? And on top of that, if you go nationwide, then definitely you need a online presence. Website will be created, and this is where e-commerce generated. E-commerce came into picture because of this requirement. Your business is growing to such an extent, and if you want to give access to your business to all the customers, then you will have to start having services over internet. E-commerce came into the picture. Now, as soon as you talk about website, the amount of data that you are generating would also increase because the scope now has increased. But at the same time, the data that we are recording is becoming unstructured. On website, you will take pictures and post it for your products, right? Specifications and all those things. There will be ads, videos explaining about the products. There will be a lot of text data that will be there. So a lot of unstructured data is getting generated. In fact, feedback was also there. This is also in textual format. So unstructured data is coming into the picture. Now, till here, there was no unstructured data. So RDBMS softwares were good enough to handle. Even if your right requirement is big, like 30 GB per day or 1 TB per day, if you invest right heavily, then you can use servers which can right help you store the data and process the data. But as and how unstructured data comes into the picture, your RDBMS softwares do not support. They do not work here. Not good enough because RDBMS softwares can only hold structured data, which is always in table format, right? So this is where we see the limitations of your existing softwares. And we see the challenge with the current system. So we have to enter the big data. So you understood that the entire transition of businesses, right? Right from doing the transactions manually to getting everything automated, thanks to the point of sale counters here, right? You have the QR codes and the barcodes on the products, which will help you to capture the transactions online, digitalized. And on top of that, these retailers are coming up with loyalty membership programs where they try to map what transaction to, each transaction to different customers. Whoever is making the purchases, we map the transaction to that particular customer. This way, I will be able to do a lot of analysis, right? Customer analysis. So once unstructured data comes into the picture, variety is coming into the picture, the traditional softwares, even if you have the capability to procure the softwares would not support. So we wanted to have a new age systems. And this is where your big data tools came into the picture, right? Now, there is a big challenge that we will see with respect to the historical data, that is RDBMS database softwares, which was discussed here, RDBMS, right? So there are big challenges. We'll try and understand what those challenges are also with respect to your big data. And if you see, once your online portal is started, once your business becomes more online, digitalized e-commerce, then you have a lot of these analysis that you can perform. These are something which organizations are already doing. Only a snapshot, guys. A number of different things can happen with respect to your data like this. Yep. Right. So you understood, right, everyone? Any questions in the journey? What is not big data? This everything is big data, Gautam. Yeah. Nowadays, nothing is regular data. Yeah. Especially with the continuity of the business over a period of time, it becomes big data. Even if you say today, if you have a startup, today it is not big data, but after a few days, it becomes big data. Yeah. Any questions, anyone, friends? Anyone? Do we have any questions in this example? We are trying to understand the transition of businesses and how different scenarios came into picture. We have seen why database softwares came into picture. We have also seen how e-commerce coming into the picture, right? Whatever. Yeah. Now, you need to trigger your thoughts. Rishabh, that is exactly what we are trying to learn today, Rishabh. Not today, as part of this big data sessions. That is what we have to think about, right? That is what we have to learn. Right. So think about the challenges, guys, now. We have seen how the transition happened. But can you think about what kind of challenges we would have faced when you're doing this kind of businesses and when we are seeing the transition? At each stage, there might be some or the other challenge, right? What are those challenges? You can talk about Saudi, the Aramco example, or you talk about the aviation example, or we talk about the grocery example. What are the challenges? Yeah. Anyone? Okay, processing speed, data, performance, computational power, storage. Yep. Forget about loss. We're talking about storage of the data. Unless until you store the data, you cannot use the data for advantage. Right? Other things come later. Storage is the primary concern. Security also comes into picture only after your data is stored in the first place. If you're not able to store the data, where is security aspect coming into picture? If I have money, then I can plan to purchase software or infrastructure. But how do I store it? Even if I have money, how do I store it? That is also another challenge that you need to look at. So the primary challenge that we need to talk about is storage. Right? Big problem. Then what is the next problem that we can talk about? Primary, I'm talking about the most important primary issues. The cost is not the primary. Yes, Ramkiran. Processing of the data is the second primary challenge. If you're able to compute, speed is secondary thing. Are we able to process or compute the data first in the first scenario? So storage, how do you store that huge amount of data that you are seeing? If I talk about 844 terabytes of data for a 12-hour flight, then where should I store one flight, right? Where should I store all the flight's data for multiple days? Where do I store it? Yeah, that's the first challenge. Then the second challenge is processing. Assume you store the data. You have all this data stored. How do you process that? If I talk about the regular systems, can you store the data using Excel, or can you store the data process the data using SQL and all that? Maybe not possible. So the challenge, how do I process this data? R or Python, that is the softwares that you know, are they good enough to process? Or if you talk about SQL, that is also something that we know. How do we process this? We cannot. Huge amount of data, right? So these are the two primary challenges that we need to look at. Most important challenges. After this, we have rest of the challenges coming into the picture, which you people suggested. Cost would be there. How do you set up your infrastructure? How much cost would you invest on the softwares? Right? That's the next problem. The softwares that were present in those years, they were only capable to store structured data. Remember, we discussed just now, right? Unless until online scenario came into picture, everything was fine. Structured data was required, generated. Structured data was generated, and the traditional softwares were good enough. RDBMS softwares were good enough. But once unstructured data comes into picture, your traditional softwares would not be good enough. Then the existing tools, those years, the existing tools were SQL, RDBMS related softwares. We used to have SQL queries to process the data. And maybe you can talk about Excel. Right? R and Python came recently after all these things come into picture, right? 1990s. Mid 1990s is what R and Python came into the picture. So existing tools cannot do predictive analytics, or they cannot handle complex iterative tasks. If you talk about Excel, Excel has limitations with respect to loading of the data also. I think it cannot store more than 1.2 billion records. Anyone has idea? Anyone who's familiar with Excel? Gautam, you might want to look at that question. You need to do a research, compare the tools. You need to compare. There will be multiple things that you need to record. Maybe you can do a simple Google search for comparing the two tools with respect to limitations. Yeah, 10 lakh records. Okay, I thought it was 1.2 million, but anyways, yeah. So yeah, there you go. You cannot store more than 1 million records. Then what you do about the rest of the records? If you have 1 billion records, what you do about the other things, other data, right? So the existing tools cannot handle the data, right? And another very important challenge is with respect to the scalability. Today, you are dealing with 1 GB of data. If your business grows suddenly, tomorrow you might increase and generate 1 TB. Just in one day, you might transition from 1 GB per day to 1 TB per day. Okay, assume. Is your infrastructure which you are using is capable to scale up? That is also something that we have to see, right? I want to talk about this SQL softwares, right? RDBMS softwares. Now, the challenge with this RDBMS softwares, especially if I talk about this transition, let me go back to this transition here. See, if I have 1 GB data, I'm generating 1 GB data per day. So we discussed that RDBMS softwares will come into the picture, and we need a specialized software, specialized system to have that software working on. This is where your data is going to sit. You have to procure a better system rather than this. So you're investing, right? Now, when your data is growing like this, your software, which is residing on this small server, will not be good enough to store this data. RDBMS are not easy to scale. They have fixed disk storage space, fixed temporary storage space. So these are fixed altogether. So you have to basically plan ahead on right, these software implementations. That was a big challenge in those years. I'm talking about again 1990s and 2000s. DBAs were very rare species, and they used to get huge salaries. Database administrators who maintain the softwares, they used to get paid heavily. In fact, I wanted to become a core DBA, but rather because of my IQ levels, I couldn't cope up to that level. So I know how to do it, but probably I did not have that capability. I try to be modest because I did try right, to become a DBA for almost a year or so, but I did not enjoy. I have to be very vocal here. I did not enjoy the kind of pressure that was there in this job roles. And hats off to the people who are core DBAs. It was such a pain and right pressureful job and pressurized job. So I couldn't survive. Rather, I should say that. So the challenge with right this transition that we are seeing, right? is the biggest problem for DBAs, because your business will not stay constant. It will keep growing. Now, as I mentioned, if you're changing from 1 GB to 30 GB, you have to migrate. There is something called as migration. You have to migrate the entire software, entire data, everything to a higher configuration system, right? So here, the DBAs had to make sure that their business continuity is there. They plan the downtime. They take the time stamp. Let's say they say that, hey, I require 2 hours downtime. That means the entire server will shut down. You'll not be able to do the business. So midnights, generally they used to work midnights after everybody sleeps, right? So late night office works or night shifts is what these people used to work. I did try, as I said. So we shut down the services. That means no business. Who can imagine now? Can you shut down any business now? Even for a second, we cannot even imagine that, right? So shut down the business or shut down the services, move the entire data to a new server, right? New server. You have to move the data to new server. On the new server, you have to replicate all the services that you have on the old server. The front-end applications, the database, the channels, etc., etc., etc. Everything has to be replicated onto a new system. And migration was the toughest job those days. Even if you miss a single step, then the entire migration process is gone for a toss, and you'll have a high pressured situations. It's like people will aim, should keep their revolvers facing right at your brains, and they do the counting on whether the server is up or not. They start countdown after this 2 hours, right? So that's the kind of pressure that these people has to handle. Slightest mistake and gone for a toss. And even data, not even a single record should move here and there. Everything has to be migrated, right? That was the biggest challenge. I'm not going into the technicalities more than this. So the challenge with scalability was tremendous. Big challenge, right? Huge challenge was there with scalability with this existing RDBMS softwares. You cannot afford to have these kind of situations, right? Especially now in the competitive world, you don't want to have services not being available even for a second. So if your business is growing, we expect our infrastructure also to scale up. Without any problem, your infrastructure should also scale up. So if you're handling 1 GB today, your system should support. If you're suddenly increasing to 1 TB, not 10 GB, 1 TB also, your infrastructure should support, right? That's the another practical challenge that people were seeing. So these are the primary challenges, friends, and we'll try to segregate everything into these 2 channels only. Processing, if I have unstructured data, I cannot process. The existing tools cannot be used for processing. Storage, I need to have hard disk also, right, increased, scale up to store. And if I have to purchase softwares to process and store, I need money. So though I have written all this, but ultimately everything is boiling down to these 2 primary challenges. How do I store this big data, which is getting generated at a rapid speeds, and the format is unstructured format? How do I store it? And how do I process this data? Right? So everything is revolving around these 2 questions, friends: storage and processing. Now, when I talk about unstructured data, This unstructured data or format of the data or variety of the data can be first looked at in three different forms. Structured data is something which is very cleanly explained, tabular format, right? And semi-structured data. What is this semi-structured data which does not have formal data model? What does that mean? What does this does not have predefined data model means? Right? Let us try and understand. I think I've explained. Few people have recently attended my session, wherein I was talking about the difference. So when I say structured data, what is the actual definition of structured data, friends? People who attended my session, you should be able to answer that. What is the actual meaning of structured data? It is written there, tabular format, but is that the definition? Schema, very good. Schema is the right keyword that I need to talk about here. What is schema? People who are familiar with RDBMS software, SQL and NoSQL software, they should be able to answer this. What does schema means? Not pattern. Okay, data types, the structure, very good. Schema means definition. Definition of data which is getting recorded. Definition of the data, guys, or type of data. Definition of the type of data that we are storing in the software in this format, rows and columns format, right? So this definition is given for each column, or I should say each feature. Your table is collection of rows, but each row is basically a combination of multiple features or factors or variables, and each feature has to have a definition. Now that definition in programming terminologies or in SQL terminologies we call as schema, right? It is nothing but a logical definition of your data. This schema basically allows your computer to understand the data that is getting stored here, right? And we can always talk about this table or representation in key value pair format. A table is always, or a definition of a table is always explained in key and value pair. If I talk about a table, then key is nothing but the header. Key is nothing but a header or heading, right? Or title for that column. Value is nothing but the data that is stored in that particular column. But what type of data? Is it integer? Is it a float data? Is it a character form data that you are storing there in that column? That we don't know. So we have to define it up front. That definition is called as schema. Right? So in other words, yes, we call it as data dictionary. In RDBMS formats, we call it as data dictionary or schema. Right? So this is basically your tabular format means. You can basically store the data directly into your RDBMS softwares. If you are able to do this, that means your data is structured. Because in RDBMS, first you create the table. How do you create a table? by giving the schema. You define the features upfront when you are creating the table. And after you create the table, you load the data. That means even before you loading the data, the structure is defined. So your computer can understand what data is getting into that table, right? So upfront, the schema is defined. Remember that. That's called as structured data. So not just, you cannot say arrange the data in table. What is table? Table is nothing but a defined fields collection, right? It's a collection of defined fields. That defined field, that definition is nothing but schema. Now, if I talk about semi-structured, the best example that we can talk about is XML, or in fact, I should also call JSON as semi-structured, right? Because these are not having that proper table representation or proper schema defined upfront. But you will be able to define that schema and then store the data in this format, table format. We can define the definition of the fields. You can do it, right? Though it does not have formal data model, we can create it, right? Hence, it's called as semi-structured. If you talk about unstructured data, then you cannot create a schema for your data. Not possible. If I talk about image or video, I cannot directly store this in RDBMS softwares. Directly, I cannot store it. There are manipulations that we do and then store the images and all that, but that's not a straight way, right? So you cannot define the fields for an image, right? So that's hence called as an unstructured data. There is no way I can have a predefined data model. This is called as unstructured. Examples is basically your audio file is also something that you need to look at. Text data. We also talk about IoT sensors data. Some of the sensors randomly give you data. And of course, images and videos are also there, right? Yeah. So this is basically your data types with variety that we need to understand: structured, semi-structured, and unstructured. Okay, what is this Chandu saying? Like Python and R, what does that mean, Chandu? I didn't understand your statement. You're asking a question or you're giving a statement? What are you trying to do? Unstructured data is like R and Python are softwares, guys. It is not data. No, you're making that statement now after you're attending the data science classes. Come on. What is R and Python, guys? What are R and Python? Are we talking about data here? These are programming languages, softwares. Yeah. Using these softwares, we will process data. What data we process? We can process the data which is in structured format, which is called as data frames. We can also process unstructured data like images and videos also. These are tools which allow us to process the data. Yes, unstructured data, images, we can process using these tools, especially Python is good with handling unstructured data. Image processing. Yeah. So I want to understand, Chendu, what batch you are attending now, data science. Did you finish data science or are you undergoing now? When did you start? Same question to Rukesh also. Did you finish your assignments? Okay. I would recommend you to attend DS again. No, you're getting confused. Hope you get the clarity, guys. Yeah, any confusion, guys? Okay, not if you're not doing that, then fine, Rukesh. Yeah, you scared me for a second there. Yeah. Okay, so Hadoop also work on same pattern, like we have to write algorithms in data science for processing data. We'll understand that, Abhishek. Hadoop is a framework. On Hadoop, we do that, but not directly with Hadoop. There are different things that come into picture. Okay, Pawan. Yeah, Pongal holidays. I'll inform tomorrow. Yeah, we have SQL servers which also handles. Yeah, but it will only handle structured data, right, Jay Prakash? SQL servers. The data is in table format, isn't it? It does not handle unstructured data. You need something called as new SQL softwares to basically deal with unstructured data, or NoSQL. NewSQL is nothing but right new updates to your SQL servers. SQL softwares plus capability to handle unstructured data. That is your new SQL. Yes, Sangram, we'll talk about that. Yes, it is. It is. Okay, first day, a lot of questions coming in. Sangram, not Sangram, Mihir, not yet planned. We'll keep you posted on that. As Hadoop, yeah, Hadoop can be, you can integrate Python and R with Hadoop. Yes. Yeah, you should be getting Rishabh. I think you should. I need to check Rishabh. I'll check. Ashnar, nobody is using MapReduce in practical sense. I can talk about MapReduce, but I don't cover that. I really do not enjoy that, but I can show you how it is done. Yeah, we'll not deep dive into MapReduce, but yes, we'll talk about MapReduce functionalities and all. Linux, yes, having Linux knowledge is important. RDBMS like MySQL has a new version which can, yes, that's called as new SQL, Mahesh. What we use for face recognition? Deep learning algorithms. You can use Python. Recorded sessions, you already have recorded sessions, if I'm not mistaken, in LMS, pre-recorded sessions would be there. But these sessions can also get added to these sessions. Seshi, is that important? It is around 40 hours, yeah. 40 hours, Abhishek. All right, yeah. So let's proceed. Let's proceed further and try and understand what we discussed today. So we have tried to understand how businesses have transitioned from manual processing or manual way to digital transformation. In this journey, we have understood how different softwares actually aided the businesses to better approach their customers. This is where we talked about SQL servers, that is SQL based software, that is RDBMS. And we've also understood how e-commerce actually came into the picture, or why it came into the picture. right? So this is something that we understood. Then we also understood big data definition. Yeah, we talked about big data definition, and this is explained with V's. Though there are multiple V's that are used to explain, I personally talk about 3 V's, which is volume, velocity, and variety. But because of the ever-changing, ever-evolving technologies, and of course the data, we also have something called as veracity that we need to look at because of the volume of the data that we are actually collecting. We need to make sure that the data that we are using is true data. Then we also have various other V's. So 4 V's come into the picture, but remember 3 V's actually form the crux of definition for big data, right? And then we have basically looked at the challenges that businesses have encountered while they are doing the businesses and how the transition happened. And these challenges are broadly classified into 2 primary things. One is the storage. How can I store that humongous amount of data? And how do I process this humongous amount of data? Now, along with this, we'll also have to look into the cost factor, the factor which also talks about the capability of the existing tools to handle this data, especially when you have unstructured data. And another primary aspect is scalability for your business or infrastructure to grow based on your growth of the business. So these are the challenges that we have to try and address. And along with this, we will also understood the difference between structured data, semi-structured data, and unstructured data. So that's about your variety. So as part of today's class, we are basically talking about, or we are trying to understand why big data is becoming so pivotal for your businesses. We're trying to understand the dynamics, guys, right? And tomorrow's class, we will be further discussing on how these businesses actually found a solution to work on this big data. How do I solve these challenges, right? So we'll try and understand that in the next class, that is tomorrow. But let me see a few questions. What is the, we will understand that, Sangram. As part of this, right, we will discuss about something called as H-base. And you will be able to understand the difference. But I would recommend you, Sangram, to go through the recorded videos which are given for you with respect to SQL and NoSQL training. I recommend you to go through that. Gautam, please hold on. There's too many things that you're asking at the first day. It's just starting now, so we cannot go to that level. We'll discuss. We'll discuss all those things. Everything will be covered. The difference between Hadoop, Spark, we'll compare them. We'll also try and understand the difference between SQL, NoSQL, right? All those things. Yeah. Right. So, yeah, guys, come on. See, what you're asking is how many sessions? What do you mean by how many sessions? We'll try to cover. I said 40 hours of session. We'll try to cover that. So you can calculate. Study material for this particular session, it should be there in LMS Sangram. If it is not there, probably we need to fix that. I'll check that. Okay, any questions related to the discussion that we had? Yeah, focus on that. Other things we can take offline also. Yeah. Okay, fine. So I see no questions pertaining to the discussion. All right. So what's the time now? No, we have some more time. Okay, veracity of data means uncertainty of data. Not exactly uncertainty, Akshay. We talk about the truthfulness of the data. And that's more important for us. Yeah, not uncertainty. Yeah. I would want you people to explore something. I would try to show you. Let me see if I can show you that. Um, Toyota truck landing saving airplane. Yeah, 2011 ad. Look at this ad. I would want you to go through the ad. I don't have audio, so I don't want to do this. Look into this video, okay? You'll understand what exactly I'm talking about with respect to veracity. This is in news which says a landing gear faulty aeroplane was saved by a truck. Yeah, look at that. There is this truck going here. And yeah, aeroplane lands on that truck. This is a news channel. Yeah. Yeah, look at that. So try and understand that. It's a news, right? It's a news. So what exactly happens here is, I mean, for this ad, right? This is an ad. I'm saying this is an ad. It is not a true fact. It's a very innovatively made ad, which basically gives an impression that this is actually a true incident, a real incident, right? So that is veracity for us. How true is that data that we are consuming? Yeah. Got it? Go through it. Go through it. When you see it for the first time, you will feel that it is true. All right. Okay, let's say there's a question here. As we use Hadoop when data is 1 TB and more, just like that when we use, who said we have to use Hadoop when I have 1 TB data? Prasad? I can use hard disk. I have laptop, which is capable of storing 1 TB or 2 TB also for that matter. Right? So that's the wrong impression. We'll discuss Hadoop, Prasad. It's too early. Hold on. We'll discuss about all those implementations, right? So yeah, you'll change your perception after the class and after a few classes. Okay, 1 petabyte. Yeah, maybe. I don't need to use Hadoop, but I can use a similar concept. But yeah, if you say Hadoop, yes, I can use Hadoop. Spark is also to do something similar on those lines, but yeah, it's only for processing. Okay, how big data analytics engineer? How big data analytics engineer different from data scientist, because there are different positions. Yeah, this is a relevant question. I'll take up this question. See, when we talk about data analytics, right? You're expected to learn statistical computing. You're expected to have machine learning. You're expected to have deep learning in some cases. You're also expected to do data analytics. For example, Tableau, descriptive and predictive analytics. Right? How you do it? Generally, we use Python programming or R programming. Now, when I talk about data engineer or data engineering, he is expected to generate data pipelines. When I say data pipelines, one of the tasks, okay, one of the tasks. You need to get the data from either SQL or NoSQL softwares, create a pipeline so that you get that data into some area. It could be cloud or it could be Python. Generally, nowadays we're talking about cloud infrastructures. And here, once the data is generated, you pre-process. That means this part now. Here you are doing this part. And then this data has to be again, once the process data is obtained, we'll do machine learning or prediction or deep learning. And then we generate the results. Those results go back to store here for future purpose. And this is also coming in the reports, Tableau use. So if you see, data engineer is also doing this task, the data pipelining task. So that means he should be well versed with the technology. When I say technology, he should be able to have SQL knowledge, NoSQL knowledge. He should be able to have cloud knowledge. There's something called as distributed computing. That is what is important, and your cloud is based on this. So you need to be able to use this capability and then do the analysis. Right? Yeah. Data lakes. Have you heard about data lakes terminology, anyone? Guys, data pipelining means the flow of data. You can also call it as data lakes. Where is your data lying? What is the software that you're using? It could be a software where we basically call it as RDBMS, right? These are your sources or NoSQL. This is where your data is stored. Okay, database. This is where your data is getting stored. Now live data I'm talking about. I want to process this data. How do I do it? I need to take the data to a different system. I cannot directly work on this. I need another system where I can process this data. I can generate a lot of reports on that data. So I need to get that live data. How do you get the live data unless until you create a channel? This channel, which allows you to get the data, is called as a data pipeline or data lake. The entire flow is called data lake. This is a pipeline. Here you are going to do the analysis. It could be a cloud platform or your big data platform or anything. And this generated reports will basically be published on your application using some Tableau or any other BI tool. And you'll also store this data back, the results back into your database. So you should be able to to work with this. Okay, Abhishek, as a data scientist, you work with PySpark. You work with SQL queries, right? I want you to work with NoSQL database. Yeah. As a data scientist, is that your primary role? What is your primary role as a data scientist? Analysis, not Python. Your primary role is to perform statistical computing or machine learning computing and analyze the data and generate the reports. When I say analyze, you can do descriptive or predictive analytics. That's your primary role as a data scientist, and map these things back to business. That's very important. But for a data engineer, your primary focus is to work with the tools. You may be doing this, but the primary thing that you will be doing is dealing with these softwares. Right? So there is certain segregation of the roles and responsibilities between data scientists and data engineers. And a lot of organizations, they are overlapped also. And because the demand is growing, data scientists are also now learning these concepts. It's important, it's pivotal to be aware of these concepts also. So a lot of overlapping is happening. Yeah. What is funneling? What is funneling? I don't know. I don't know what is funneling. Yeah, you can say Abhishek, but when you say full stack data scientist, not analyst, data, generally we use full stack data scientist as a terminology. Then yes, you can say, yeah, part of that is data engineering also, yes. Yes, Sangram, that's correct. Yeah. Yes. See, expectations are growing, Mahesh. That's the challenge. As an organization, I want a fresher to have 10 years experience in automobile industry, in life sciences, healthcare, working on at least 10 projects. As a fresher, he needs to have 10 years experience in these industries, right? That's my expectation as an organization to hire someone. How can a fresher have 10 years experience, man? Right? So yeah. Yeah, Srihari, I'll be talking about all these in bits and pieces, but when you're working on a project, you will have to combine everything. All right, so we will conclude the session. We'll connect tomorrow and we'll keep this interesting discussion going on. It's more of understanding the implementation and understanding the tools is what we have to focus on this particular sessions, guys. Okay, so yeah, thank you guys. We'll try and connect tomorrow. Thank you. Good night. Yeah, we'll keep discussion tomorrow, guys. Yeah. Hold on to your questions. Yeah. Good night.